Okay, hello everybody out there. We're going to go ahead and cover some stuff today. It's just some stuff on the side that needs to be covered. So first off, we're going to do types of forces. So the first one there is weight, also known as gravity. All right, so I'm not going to read this whole thing. I'm just going to give you the cliff notes and highlight. All right, so force of gravity is the force at which the Earth, Moon, or a planet you're on pulls you towards itself. So it's, a larger object will pull a smaller object towards it. So directed in a downward fashion towards the object. All right, so force of gravity, aka weight, is mass times gravity. Where on Earth it's 9.8 newtons per kilogram, but for purposes of being neat, we are going to go 10 newtons per kilogram when we do these problems. All right, next type of force is normal force. Normal force is when a force acts upon an object that it is touching. So it actually has to be sitting on something or touching something to actually have normal force. All right, spring force is easy. It's the force exerted by a spring. And there's the equation for it. All right, sliding frictional forces. All right, frictional force is a force exerted by the surface as an object slides across of it. So the force of friction is known as little u times the normal force, which we will go over later on when we discuss other stuff. All right, air resistance is a type of friction caused by air. So that's air resistance, the force of air. All right, tension, force transmitted through a string, rope, wire, or cable when it's pulled tight. Okay, applied force is simple. It's the force applied by a person or object. All right, so that's easy. So we have weight or gravity, normal force, which is when an object is on an object, spring, it's force from a spring, friction comes when the object is sliding on a surface, air resistance, aka air friction, tension from a string, rope, or cable, or anything something's from, or applied force, which is basically a force that is applied by a person or a thing or an object. All right, so we'll take this and we'll say whether or not they force is present. So we have this. It's a block hanging at rest from a piece of rope. So it's hanging, so force of gravity is present. Spring, nope, no spring. Tension, yes, because we have a rope. It's hanging on a rope. Normal, no object resting on another object. Friction or air resistance, no, it's at rest. Okay, 2. All right, so basically this is the same, except it's hanging from a spring. So we have spring, tension, and we have gravity. We do not have tension anymore because it became a spring. And everything else is the same. All right, ball thrown into the air. Of course, it's in the air, so gravity is present. There's no spring involved. It's not hanging from nothing. It's not leaning against something, so there's no friction because it's not sliding, but there is air resistance. All right, skydiver. Skydiver is pretty much going to be the same as the next guy. All right, now just for purposes here, he hasn't opened his parachute yet. Because if he opened his parachute, we'd be adding this to it. So yes, there's gravity, there's no spring, there's no tension because he hasn't opened the chute. It's not against anything, so there's no normal force. There's no friction, he's not sliding. but he is falling through the air. So basically what you have here is you have the force of gravity pulling him down and force of air. Same thing on here. On this one, you have the force of gravity and the force of air. Alright, so this next one we also have two forces working on it because it's at rest on top of a thing. Of course, what's pulling it down, what always pulls us down, is gravity. There's no spring involved, no rope or anything. Normal force, yes, it's resting on something. So guess what? This is the force of normal. It's not sliding or moving, so there's no friction. Alright, but it is on the surface, so you could say it has some friction, but not very much. It's when you push it, there will have friction. Okay, that brings us to weights. Alright, standard metric unit for mass is kilograms. Standard metric for weight is Newton. Alright, standard equation for weight, mass times gravity. And we know gravity is, in our case, 10, we're going to say 10 meters per second. So, the object's mass refers to D, the amount of stuff present in the object. The object's weight refers to the gravitational force. So D and B. Alright, here's where we use this. So we have 1 kilogram, so 1 is the mass, 10, so 1 times 10 is 10, so it's 10 newtons. Alright, we have an apple with a weight of 1 newton. So it's going to be 1 divided by 10 after you rearrange it, so it's going to be 0.01 kilograms. And Mr. Pat over here, 25 times 10 is 250 newtons. That is a really small person at only 25 kilograms. Alright, so 1 kilogram is 10 newtons. 5 times 10 is 50. 70 times 10 is 700. Alright, so we're not going to worry about converting this over to on the next two. Alright, so 7. What is the mass and weight of a 10 kilogram object on Earth? Alright, so 10 kilogram object. Wow, they already gave us the mass. It's 10 kilograms. Weight, though, is 10 times 10, so it's 100 newtons. Alright, mass of the 10 kilogram object on Moon, where the force of gravity is 1/6 that of Earth's. Alright, so mass does not change. You can't change the amount of matter. So it's still 10 kilograms. But meanwhile, weight can. So basically it's 1/6. So 100 divided by 6 is going to equal 16 point, we'll just round this off to the nearest tenth, 16.7 newtons. So that is a lot less. Now your conclusion is the blank of an object is independent of the object's location. So it's independent because, yeah, mass is independent because no matter where it's at, so it's the same. Alright, with that, I'm going to pause and come back.